Okay, for what you need to know for your quiz and your test, you need to know e to the x, sine of x, cosine of x, and 1 over 1 minus x. So what's e to the x? It's kind of nice to see them all together. You could do, you could derive it. Who wants to do that? We did this one. This wasn't too hard. What? I was thinking something in the back, but they're going to... Okay, Natalie, what's e to the x? Well, we did it in class. 1 plus x squared over 2 factorial plus x cubed. Because what's the derivative?
The derivative, like finding the zero?
Yeah.
Oh, so it's just...
Well,
so really, you just need to know
did you guys watch the video? No. By the way, you don't even have to go to Schoology because they're public on YouTube. All you have to do is search for Golden Bess. Well, YouTube works. Okay, you need to know that one. Now, we've done the cosine. We did that yesterday. What's the cosine?
That's just because the derivative of 0 is always 1, so it just kind of goes away.
Yeah. Because all these coefficients are derivatives. Okay, what's the cosine of x? By the way, is it odd or even? It's even. They all have factorials. This one doesn't. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. They're in your book. Minus x to the 6th over 6 factorial. And it's minus 1 to the n. You have to be able to write the nth term. X to the 2n over 2n factorial. So since cosine is even, sine is odd. It's also the derivative. It's the negative derivative of the cosine. So this is x minus x cubed over 3 factorial. These are easy to remember. Plus x to the 5th over 5 factorial. Well, they're all over factorials. Sine and cosine are alternating series. E to the x, if we were to add these together and they weren't alternating series, you get e to the x. Okay, minus x to the 7th over 7 factorial. Negative 1 to the n. X to the what? 2n plus 1, assuming I'm starting at 0. 2n plus 1 factorial. And you could integrate these. You could do e to the x squared by just substituting x squared for x. It doesn't matter. Those are all families and relatives too. And there's a way to combine it with sine and cosine, but beyond our course. And there's a totally different family. There's the geometric one. What's this one? You should know this one by now. X plus x squared. You know what? It looks like e to the x, except it doesn't have the factorials. And we're going to review what a Taylor series is again. Yes. Yes. Power series. All of these are power series. Taylor gets the name because Taylor came up, supposedly, with the process of how to find them. But any series that's a series of powers is called a power series. So these are all power series. Using a Taylor polynomial is a way to find the power series. Okay, Matt? What is a Taylor polynomial? What's the first term? And then we'll put the Maclaurin up there. And that's what the test is on. It's f of a plus f prime of a x minus a. Now, do you see that that's just the linear approximation? That's the equation of the tangent line. And we center the equations of the tangent lines at places that are convenient for whatever the problem is. It doesn't have to be centered at the origin. So it's where you draw the tangent line. That's what you mean by centering. Plus, then it's f double prime of a x minus a squared over 2 factorial plus f triple prime of a x minus a cubed over 3 factorial. Do you see the pattern there? You're in your project, you were supposed to generate the pattern, figure out how we came up with the pattern. I don't know. I haven't looked at them. I haven't had time. So it's the nth derivative at a, x minus a to the nth over n factorial. And if you center it at the origin, we just hope that on the exam they do center it at the origin, then we get the Maclaurin series. Why don't we call it mn of x? Well, a is 0, so it's f of 0. If I can write 0. Plus f prime of 0 times x minus 0, but that's just x. Plus f double prime of 0, x squared over 2 factorial. Plus f triple prime of 0, x cubed over 3 factorial. And it's the nth derivative at 0, x to the n over n factorial. And if you have an alternating series, you can use the alternating series test, which is actually very similar to the Lagrange error bound, which we will not deal with until May. But the alternating series error you should know from what we've done in this chapter already. And that's really, honestly, that's all there is. Now, what's interesting is these derivatives divided by factorials, those are those C values, those coefficients. They are simply numbers. They don't look like numbers, do they? That is a number. It's the coefficient of the x to the n power. That's all it is. That is a number. I know it doesn't look like that.
And are we allowed to use the Maclaurin?
If they tell you it's Maclaurin, they center it at 0, yes. Now, knowing that this is just a number, you know what the second derivative is divided by 2 factorial. It's whatever that coefficient of x squared is. They don't have to tell you how they got the polynomial. They can make anything up that they want. And you know what the first derivative is. And you know what the value of the function is at 0. You know all those things on the polynomials. In fact, we could look at the problem that actually did that. 2011 is very similar to 2010 problem. They do write these 2 years in advance. So I don't know. You probably can go back to 2009 maybe and see what kind of problem they wrote. Or maybe you can look at 2010. 2010 and 2011 were very similar. But I remember there was one that asked you what f of 0 was. Well, that was pretty easy. It's the first term in your polynomial. Okay, so if you, whoops, I don't want that. Back. That one.
Like the quiz one, just like twin, right?
It's formative. You'll get it back. I'm quizzing all day tomorrow. You get it back on Thursday. Okay, so here's last year's exam. Write the first 4 non-zero terms of the Taylor series for the sine of x. How hard is that? Oh, it's Taylor. It's round x equals 0. It's Maclaurin.
They always have a Taylor series, FRQ or not.
Yes.
I want to say first non-zero x.
Okay.
Just they don't want the 0 terms. Because if I go back to sine, these are the first 4 non-zero terms.
So what are
Because what's x squared? It's 0.
And then you just do x squared times that.
I don't know. I gotta look at the question. Is that what they asked me?
And then it says, and write the first one.
No, not x squared times that. What are you gonna do? Replace this x with x squared.
Yeah, that's put it in.
Yeah. Should we see how many points that is? That is, I won't reveal all the answers. 3 points, that's 1/3 of the problem. The average is usually 1.5.
Oh,
So that's, like I said, they're throwing you a bone. They're giving you a gift.
and it always does that? And then always
They- They always have a Taylor polynomial. What it looks like, I don't know. Then you got to go back. Because that's a gift. Throw the dog a bone, you know. Okay. Then, ooh, look what's the next one is, write the first 4 terms of the cosine function. By the way, the average on this was 4.7. This was last year's, yes. So I just copied it. And then you add them. That's why it was so high.
Can you do the end part for,
If it asks for it, yes. If it doesn't, don't.
so what is that called?
The nth term. Okay, you guys. If they ask for only 4, don't do more than 4, because you'll be in big trouble. And then guess what we're going to do with these? You can do the cosine, right? Look at that. Another point. We're up to 4 points, and then you have to add it. How hard is that? No. Do it. Go ahead and do it. Want me to leave the answers up there and do it? You need to write it out and do it. Yeah, don't copy it. Do it. Well, first you do what the first thing says. Write out the sign of x. Would you like to come up and do it on the board? Yeah. You'll know how to do it then.
David, you can have it.
Who's going to come up and do it? My feet are killing me. No, no, no. I have a piece of glass in my foot.
What am I doing? You should probably take it out.
I know. I tried to go to the doctor and get that done last night. But he wouldn't do it. You can't. It's too little. It's like, I don't know how they're going to get it out. They're going to have to cut off half my foot. Okay, do A. Doc A. Yeah, start at the beginning. Don't say you don't know how to do it. I'm going to come and visit you. Okay, we're going to turn the sun. Well, they might give that. You get 2 points for f of x. So you certainly get 1 point for trying to add it. Whoopsie. Where is this? Okay, here's what we have, right? We have these two, and we want to add them. That's right. It doesn't matter the order. So it's x squared minus x to the 6th over 3 factorial. Plus, how many terms do they want?
They want it for the first one.
Oh. Okay. I'll put this in, but I'll cross it out if I don't need it. 5 factorial plus the other one plus, and then it's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And let's try to get that in order, because I don't want to do too many terms. The fact that you try to add them is probably going to be worth a point. So we always put these in order. Let's see what's next. X to the 4th. How many terms did I want?
You want the first one.
Okay, so I don't want that guy. I don't want that guy. Oh, but I need x to the 6th. Oh, whoa, I can't count.
Don't you have to come
I can't count. This is only one term, isn't it? Because can't I do this x squared, and it's 1 minus 1 over 2 factorial, plus x to the 4th, and guess what? There's got to be another 6th term. Minus x to the 6th, it's 1 over 3 factorial. What's the next thing?
And then 1 over 6.
Okay, you got to use this guy. Minus 1 over 6 factorial. I factored it out there, didn't I? Okay. Doesn't matter. Okay. That's worth 5 points. Doesn't really matter. Well, I'd rather have that plus, make that minus plus. I'd be happier. Okay, what's the next question? Next question says,
I do not understand that adding thing for one minute.
all I did was add them.
Well, how did you get a
Because I didn't know I had another term, I factored a negative out and I fixed it.
So then you get
This is only one term. This is only one term. Because you could make it a single number. What is this? 1 plus 1/2 of x squared, right? Plus 1 over 4 factorial, x to the 4th. And now what? I got to add those. Ugh.
okay, you're not really adding it. Fine.
That's adding.
Yeah, the negative plus the
I don't know which is bigger. 1 over 3 factorial is probably bigger.
yeah, but okay. If you have negative x squared over 2 factorial.
Whoa. Shh. Guys, I can't hear. What?
Okay, like, you mean like what I like 1 minus x squared over 2 factorial. If you add x squared over 2 factorial, it's not negative. It's positive. Like, so why?
It's not. It's positive.
Why is it negative in the first place? Like
This is,
1 plus
I factor out x squared here. It's 1 minus the coefficient, which is 1 over 2 factorial.
I just don't get why you have it as negative x squared over 2 factorial if it's in theory adding.
Adding and subtracting are the same things. They're just opposites. Multiplying and dividing are the same operations, just opposites. One undoes the other.
No, you're adding.
I mean, it's adding the negative.
Okay? Natalie, I'm now adding them. 1 plus a negative 1/2.
If you went like
What's a negative plus a negative?
positive.
No. Negative.
Whoa. Negative plus. We have a little work to do.
Okay,
Come on, take it.
Okay. Okay, guys. Let's keep going. Guys, the more we delay, the fewer problems we get through. And then you're on your own. The answers are all online. Okay, guys. That's all it has to do. And then what do we have to do? Then what do we have to do? Okay, you guys, it wants the 6th derivative of this function. The Taylor polynomial Maclaurin polynomial looks like f of 0. What's f of 0? Yeah. I didn't do the arithmetic. You do not have to do the arithmetic. They just added those up. I just didn't do it. By the way, you do not have to do that. You'll have to do that later in the problem to get more points. We are now to 6 points, huh? We have to add those. You want me to add those? Okay. Oops. So how do you add 1 over 6 factorial minus 1 over 3 factorial? That's 1 over 6 times 5 times 4 times 3 times 2 minus 1 over 3 times 2. Now, I got to get common denominators, right? We're going to have to do it anyway. So 6, 5, 4, 6, 5, 4. Okay, I'm off the space. 6, 5, 4. What does that give you? 1 over whatever that number is. 5, 4, 3, 2, 1. And this is 30 times 4. 120. Why am I getting 119?
That's supposed to be 1 over 3 factorial plus 1 over 6 factorial.
Did I meant? Oh, I'm just going by his work. Okay. They're both negative. So we made a sign error. That's a negative. There we go. So it's 121. It's really 121 over 6 factorial. Okay? Now, what's a Maclaurin polynomial? Natalie? It's f of 0 plus f prime of 0 times x squared plus f double prime of 0, x to the 4th. Now, you guys, if you pay attention, it does get to be a lot easier. What's f of 0? 1. What's f prime of 0? Now, it's 1/2, just the coefficient. Is there an extreme value at 0? No. What this has to be true about the derivative? Derivative has to be 0. Derivative is not 0. They could ask that question. Then, oh, I forgot something here. That's x to the 2nd over 2 factorial. Okay, guys, what is the second derivative? The second, these two, oh, I'm sorry, I messed up. What is, I'm going to cross that out. Okay, hang on. It's f of 0 plus f prime of 0 times what? X. There we go. I don't know why I did. Because you guys are distracting me. You're so noisy. Okay, what's f of 0? 1. Okay, that's 1. What's f prime of 0? Careful. It's the coefficient of x. It's the mistake I made. There aren't any x's there. It's 0. Is there a relative maximum in there? Yes. What's the second derivative? You can't compare because you don't know enough. F double prime. Well, we have to find it. Now, I'm going to move my board here. Now, f double prime of 0 over 2 factorial is the coefficient of the squared term. What's the coefficient of the squared term? 1/2. Solving that equation, what's f double prime of 0? Okay, it's 1. That means my function is concave up. If it had been 0, I would know nothing. Okay? Concave up, so therefore it is a minimum. So yes, there's an extreme value at 0. Okay, so how do you find the sixth one? They want you to find the sixth derivative at 0 over 6 factorial. That's the coefficient of this x to the 6th. Natalie? This divided by 6 factorial is the coefficient of this, which it should have been both minuses here, which we figured out was this thing. So it's 121 over 6 factorial. Oh, what's the sixth derivative? I just did the arithmetic. This should have been a plus. I made a sign error. Well, I copied it wrong. Anyway, That's 120 plus 1 is 121. What is the sixth derivative? It's 121. Let's go see if we did it right. I don't know. I think we did. There it is. Well, yeah, I forgot about my sign. It's a negative 121 because if I go back to my work, it's correct, but I just forgot about the sign. See, there's a minus there. So it's minuses. Can I solve for what? How did I do the arithmetic here? It's minus 1 over 6 factorial minus 1 over 3 factorial. So I just wrote it out. Let's take the negative out and let's not forget it this time. It's 1 over 6, 5. These are multiplied. I'm just lazy. Minus 1 over 3, 2, 1. What does this one need to have a common denominator? It needs a 6, 5, 4, 6, 5, 4. I took out the negative. I forgot to make that positive. Multiply those together. 30 times 4 is 120 plus 1 is 121. You're going to have to do the arithmetic to get that point, though. And then, what's the next question? Oh, we can't do the next question. So we got 7 points. If you get 7 points, you're going to get a 5. So do we really care about this answer here? This is the Lagrange bound. Yeah, you can. Okay? Vader, do you have a question? Okay, I have to, you can go to the next problem, try it. I'll have to build the smartboard. Okay? Oops, I don't want that. Yeah. Who's messing around with my iPad? Okay, so I've got that wrong because, well, I'm not quite wrong. Look at what the n's are starting. If you start with n equal to 0, what is this? This is not 1 factorial, is it? It's 2 factorial. So I'm just off by 1, that's all. So it's parentheses n plus 1. You just have to check it with, you know, what you have listed there. Then what's, so we're to 4 points. Well, we're not done. Oh, we can do C. Use the ratio test. Do you guys remember the ratio test? No. That's in this section. You take, that's why you had to do the nth term. Now, they will do a follow-through error. As n goes to infinity, a sub n plus 1 over a sub n okay, guys, that's the ratio test. Let's see how they pointed this. Look at all the points. 3 points for setting up the ratio, even if it's wrong. 1 point for computing the limit. And then because it does have an infinite interval of convergence, you don't have to test any points. So it's 1 point more for the answer. That wasn't bad. What's bad? You guys should know the ratio test. You love the ratio test. No, you do love it. I know you do. That's right. Then it says, use the Taylor series for f, this function here, to determine whether the graph has any points of inflection. What do we look at to do D? F double prime. Okay, so we got to be careful with this. No, we're going to finish this. Over 2 factorial equals Oh, wait, we have to do a little bit more, don't we? Well, we have to see if they're candidates. What's F double prime? 1.
So do you guys seems
What has to be true to have an inflection point?
it's gotta change sign,
Change sign.
right?
Well, it's got to be 0. How can it change sign unless it's 0? So unless I made a mistake someplace.
There you go.
Doesn't look like there are any.
Alright,
Oh, I do chew.
sure.
Oh, they actually want you to compute the second derivative. Because it's time to go. Let's see. I think the way I did it's okay.
This model's gonna be on like one of those pops that we today, no packet.
Yep.